Hello everyone. In this presentation, we're going to discuss about network function virtualization. Coming to the introduction part, traditionally network functions such as routing, firewalling, and also load balancing are handled by dedicated hardware devices. However, NFV takes a different approach by executing these functions in a software. So this shift offers us a greater flexibility as well as scalability and also cost effectiveness. So let's discuss like why we need to develop NFV. So well, traditional network architectures face several challenges. Firstly, the high cost associated with dedicated hardware appliances can be very prohibitive. So for example, let's say we are purchasing and also maintaining specialized hardware for each network function can quickly become very expensive. Secondly, these appliances are often purpose built for specific functions, which limits their adaptability. So this means if you need to add a new network service or update an existing one, it often requires the deploying new hardware and also making significant modifications to the existing software. So finally, scalability can also be a challenge with conventional appliances not inherently designed for easy scaling. So as network demands grow or change, or adding or upgrading hardware to accommodate these changes, this can be very time consuming and also very costly. As there are many limitations, as I've mentioned for the NFV, we have to overcome this limitations. So we can do this by virtualizing network functions and also executing them in a software. NFV offers a greater flexibility, scalability, and cost effectiveness. So it breaks the barriers imposed by traditional hardware based approaches. So with NFV, network functions are decoupled with proper hardware and also run as software instances on standard servers, and this allows us for more dynamic and also effective resource allocation. This is the NFV diagram which outlines the architecture where the framework centrally manages virtualized network functions, that is the VNFs. So on the left side, this depicts the centralized virtual network infrastructure, abstracting how hardware resources of VNF deployment work. And on the right side, the software applications represent VNFs executing specific network functions. So this framework coordinates resource allocation, configuration, and also the management of VNF. The architecture enables flexible, scalable, and also cost-effective network management when compared to traditional hardware-based approaches. Coming to the benefits, NFV benefits us in several ways. Firstly, it reduces the amount of physical space which is needed for network hardware. So also, instead of lots of bulky hardware, NFV lets us use fewer servers and also fewer virtual machines for multiple tasks. Secondly, it lowers the energy use, which saves us money on electricity bills and also cooling systems. Thirdly, it cuts maintenance costs by automating many tasks that can be used which can be done manually. So this makes us managing the network easier, and also it is less time consuming. Lastly, NFV makes hardware last longer by running functions on standard servers, so we don't need to upgrade as often as needed, which saves money in a long-term conditions.
NFV architecture has mainly three parts. One is centralized virtual network infrastructure, second one software appliances, and third one is framework. These components work together to enable the virtualization of the network functions and the execution of the software-based solutions. The centralized virtual network infrastructure provides the underlying resources needed to the support virtualized network functions such as compute, storage, and networking resources. Software appliances represent the virtualized network function themselves, such as firewalls, routers, and load balancers, which run as software instances on top of the infrastructure. Mainly, these frameworks serves as the management and orchestration layer that coordinates the deployment, configuration, scaling, and lifecycle management of these virtualized network functions. Altogether, these components form the foundation of NFV, enabling the transformation of traditional network architectures into more flexible and efficient software defined networks. Now let's look at how NFV operates. NFV involves various processes such as resource allocation, VNF, that is a virtualized network function deployment, configuration and management, scaling, chaining, and orchestration. Resource allocation refers to the dynamic uh, provisioning of compute, storage, and networking resources to support the deployment and operation of the virtual network functions. VNF deployment involves the instantiation of the virtualized network functions on the underlying infrastructure, either manually or automatically in response to changing in the network demand. Scaling involves adjusting the capacity of the virtualized network functions to accommodate changes in network traffic or demand, either by adding or removing instances of these functions as needed. Service chaining refers to the composition of the multiple virtualized network functions to form complex services chains or workflows that implement specific network services or policies. Together, these processes ensure efficient and effective utilization of NFV in network management and enabling the organization to dynamically adapt to changing business and technical requirements. Uh, NFV offers several advantages over traditional architectures. Firstly, it leads to significant cost savings, that is, by reducing the both capital and operational expenditures, and by leveraging the standard server hardware and virtualization technologies. NFV eliminates the need for expensive proprietary hardware appliances, resulting in lower upfront costs and reduced ongoing maintenance expenses. And secondly, NFV provides greater scalability and flexibility for network growth and adaptation. With NFV, organizations can easily scale up or down their network capacity and deploy new services or update existing ones without the need for costly hardware upgrades or replacements. And thirdly, new services can be deployed faster with NFV, accelerating innovation and time to market. Since network functions are implemented as software instances, they can be rapidly provisioned and deployed in response to changing business requirements or market demands. And finally, NFV eliminates the need for hardware modification, uh, qui- that is quicker innovation and revenue generation potential. By decoupling network functions from the proprietary hardware appliances, NFV enables organization to adapt new technologies and that can serve services more quickly, driving revenue growth and competitive advantages. In this summary, NFV offers a compelling value propositions for organization looking for modernized their network infrastructure and achieve greater efficiency and innovation.
Now coming to the disadvantages. Despite its advantages, NFE does come with challenges that organizations need to address. Firstly, it needs to seamlessly coexist with physical network devices, especially in hybrid cloud integrated environments. Balancing virtual and physical components is crucial for smooth operations and ensuring interoperability between different parts of the network infrastructure. Secondly, ensuring efficient management and monitoring of virtualized functions in abstract IT environments can be challenging. Unlike traditional hardware based networks, where hardware is directly managed and monitored, NFV operates more abstractly, requiring specialized tools and processes for effective management and troubleshooting. Thirdly, NFV environments are dynamic, requiring effective handling of varying workloads and traffic demands. Scaling up or down based on demand while maintaining performance and stability is a challenge that organizations need to address through effective capacity planning and resource management strategies. Lastly, organizations adopting NFV must realign their processes to manage both traditional and virtual infrastructure simultaneously. This includes provisioning, troubleshooting, and security practices, which may require additional training and expertise to ensure smooth integration and operation. Successfully addressing these challenges will enhance NFV's effectiveness and contribute to more efficient network management, enabling organizations to fully realize the benefits of NFV in terms of cost savings, agility, and innovation. Now, coming to the functionality part, NFV displaces conventional network hardware with adaptable software deployed on standard server problems. This shift empowers IT professionals to upgrade their networks more dynamically, enabling them to respond quickly to changing business requirements and market conditions. NFV finds applications in data center operations, including firewalls, load balancers, intrusion detection and prevention systems, WAN optimization controllers, and more. By virtualizing these network functions and running them as software instances on standard server problems, organizations can achieve greater flexibility, scalability, and cost effectiveness in their network infrastructure. Additionally, NFV enables the implementation of network functions as software defined services, allowing for more agile and efficient service delivery and management. In summary, NFV represents a fundamental shift in how network services are deployed, operated, and managed, offering organizations the opportunity to modernize their network infrastructure and achieve greater efficiency, agility, and innovation in the digital age. Now, here are some of the references we have used to add content to our presentation. Thank you so much. I hope you had a great idea about NFV through our presentation. Thank you.